All right, guys, we have the last section of our calculus prep today. Three pretty straightforward problems, and we'll probably go through these pretty quick. Hopefully, it won't be too long of a video. Number one, we have two triangles. If you can see there, we have the big triangle, and then we have a smaller triangle. So we're going to use that to our advantage, knowing that they are similar because they have two angles that are the same. Therefore, the third angle is the same. Therefore, they are similar. So I'm going to say that R over H is equal to, because proportions, equal to x plus t over t, because this whole entire thing is x plus t. Now I'm trying to solve for x, express x in terms of everything else, so I'm getting x by itself. So we cross multiply here. I get RT is equal to H times X plus T. Next thing I would suggest doing is distribute. So I get RT is equal to HX plus HT. Now I'm trying to get X all by myself, so move HT over. So I get RT minus HT equals HX. Then last thing we do is divide both sides by H. And so X is going to be RT minus HT over H. That's as far as we can go. All right. Our second example, we're dealing with cutting a piece of wire into two pieces. They both make a square when we fold them. One is smaller than the other, but all the sides are the same because they're squares. I'm going to call this side X for the square and this one Y. Now it says to use one variable to write the expression for the subs. Well, their areas is x squared plus y squared equals the sum, s. But that's not good enough. I'm using two variables. So if we can use our perimeter idea, well, if I have 4 of these, that would be 4x, plus 4 of those, that would be 4y, and then these all came from the 24, so that equals that. So if I wanted to use one variable, perhaps I could divide everything by 4. I would get x plus y equals 24. Nope, equals 6 rather. And then from there, I could solve for one of the variables. I'll solve for y. It actually does not matter. And I'm going to take that and put it right there, and then I'll get my one variable. So I have x squared plus 6 minus x squared equals s. I have my one variable. I have everything expressed as a sum. We're good to go. One more. Let's see. Caleb is kayaking. We got to figure out what this one is. I'm going to call that y. We might as well call this one x. And then they said the distance is d, so that's d right there. So I know x plus y equals 12. And then I also know that d squared is equal to 5 squared plus x squared. Excuse me, because of the Pythagorean theorem, which says a squared plus b squared plus c squared. Now, how do we know this is a right triangle? Well, this is due south. So we are taking a little assumption there, but I think that's safe to say that that is a right triangle. All right, once again, we just want to solve for this distance PL, so we're going to solve for y. So I'm going to move x over. But we want it as a function of d, so I'm going to solve this one for x, so I get d squared minus 25 equals x squared. I take the square root of both sides, and that means that x is just going to be the square root of d squared minus 25. We can't break that down at all. So I'm going to take that, plug it in, I'll be done. So y, the distance between p and l, is 12 minus square root of b squared minus 25. And we have rewritten it as a function of d. We're good to go. We'll catch y'all later. Bye!